my name is Santiago Prieto and today I'm gonna show you how to use the Texas Instrument 84 plus C calculator for finance purposes. So, today we are gonna see three cases, one of a compound interest, one of an annuity, and one of a loan repayment with different terms. For solving these problems, we are gonna need the GDC calculator and the TAVM solver. For going there, we're gonna go to apps, then finance center, and then TVM solver enter. And here we're gonna put our data to solve our problems. So the first problem is Ambiga invests 8,000 Malarian ringgit in a bank offering 4.6% interest per year compounded monthly. What does this mean? First of all, we're gonna put our data here first. So Ambiga invests 8,000 Malarian ringgit. So our present value is 8,000 because this is the value we start with. Then our interest is 4.6% per year. So we're gonna put here 4.6. What also we know, this is compounded monthly. So what does that mean? This is base per year and compound per year. So we're gonna put here 12 and 12 because this is compounded monthly and there are 12 months in a year. Then the first question is how much she will have after 7 years. So here we're gonna put 7 years times 12 because she's gonna make 12 pays each year for 7 years. And for PMT, that is payment, we're gonna put 0 because she's not making other payments, and future value, we're gonna put 0 because this is the variable that we are going to see on our calculator. So n is 7 times 12, interest is 4.6, present value, I recommend you to put this in negative, so the GDC is going to give you the future value in a positive value. Then so we put this negative, not the other one. 8,000, PMT 0, future value 0, payments per year 12, and a compound per year 12. Future value, we're positioning ourselves here, press alpha and then enter to solve, and this is going to give us 11,032.28471. This is gonna give us the answer that is 11,032.28471. And let's see if this is correct. Yes, this is correct. So what does that mean? This means that Ambiga is going to have 11,032.28471 Malarian ringgit after 7 years. So the next question is, how long does it take for her money to double? What does this mean? This means that we need to know how long it will take for her to double her money. So how do we know what is the double of her money? It's simply the present value, that is 80,000, times 2, which is equal to 16,000. So what are we gonna do here? It's exactly the same thing, but now we put our future value in 16,000. So we will know how many time, this is the variable that we will find, will take to go from 88,000 negative. So we need to put this negative so the GDC doesn't crash, because if two values are negative or positive, it doesn't work to do this. So we're gonna go here 0 and here 16,000, then to n, and to find we are going to do alpha enter. So the answer is 181,000, no, 181.1673562. This is in months because we put this compound and all this in months. So to give it in years, we're gonna divide this by 12. So here we can go there and divide by 12, and the answer is just 15.09, etc. And this we are going to put this like 16 because he's not gonna double his money. Her excuse me, her is not gonna double her money in 15 years, but in 15 point da da da. So she will take 16 years to double her money. And as you can see here, this is the value that she will take to double her money. The next exercise, the second statement says Sarah Jane saves £1,500 each year into an annuity that pays 3.5% interest per year for 30 years. How much will she have saved? So let's put this in our data. So first of all, we know that she's saving money each year. So this 1,500 is going to be here in payments because she's paying this amount each year for 30 years into an annuity that pays 3.5%. So we have 3.5% interest. What is the present value? 0, because she's starting with 0 pounds. What are we trying to find here? How much she will have after 30 years, which is the future value. So we're gonna put this to 0 and find this variable. And payments per year and compound per year is 1 because she's not making any compound monthly or anything like that. So we're going to put our data here, and 30, 3.5, 0, 1,500, 0, this is the value that we are finding, 1 and 1. So we select the future value, alpha, and enter, and this is that she will have 77,434.01592 pounds after 30 years. Let's see if this is correct. Yes, she will have the same amount. So this is how you find what you will have after some time with an interest and yearly payments. The third exercise is about loan repayment. This will have 3 parts, this question. So the statement says Sammy takes out a loan of 150,000 euros at 5% interest per year. First question says, what is the monthly repayment when the loan is for 20 years? So here we'll put our data here. That is the years, 20 years times 12, because he's doing monthly payments. Then the present value, that is 150,000 pounds. The PMT is the value that we are finding. The interest rate is 5% per year, and the payments per year are 12, so the compound per year is 12. The future value is going to be 0 because he's paying this. So after putting this, I forgot to multiply here times 12. We are gonna be able to find the PMT by selecting it and then alpha enter, and this says that the PMT is 989.933688. Let's see if this is correct. Yes, this is correct. So he is paying this amount each month to repay the loan of 150,000 pounds. The next question is monthly repayment for a 10 years loan. So here we are going to change this value because it's no more 20, but it's 10 times 12, 5, present value is here, PMT 0, this is what we are going to solve, future value 0, 12, and 12. So the only change here is that here we're going to put 10 times 12, which is 120, and here's 0, alpha, I'll enter to solve. Here it says that his monthly payments are gonna be 1,590.982729 pounds each month. Let's see if this is correct. Here it says that it is correct. So the third question is compare monthly payments and total interest paid. For this, we are gonna need to compare those two values that gave us here and here. So first of all, we're gonna need the PMT multiplied by the number of payments, which is 989.933688 times 240, and the other one here is payment times number of payments, which is this here, 2009 times 10 times 12, which is 120. So here we can multiply this with payments times 120, which give us this value here, that is 190,917.9275, and the other one we're gonna need to calculate here because I already erased it. So 989.933 6088 times 240, which is this number here. So these are the total payments in each loan. So here we can see that these are the monthly payments in total, but we need to know also the interest paid. So to know the interest paid, we are just going to subtract from this the present value, which is this one and this one. Ting, ting, ting. So here we're gonna put this value that is. So one tip that I can give you is that here you can select this, put enter, and the value is going to copy there, so you don't have to write all this again. And this minus the present value that is this here is going to give you this amount. That is correct. And the other one, we are going to have to write it again because I already erased it. 17.925 minus initial value is gonna give you 9275. This is the total interest paid in each loan, and we can see that this one is almost the double that this one. So we can conclude that the 10 years loan is way better because we are paying less interest. So in conclusion, we can say that today we learned how to find the compound interest of an investment, the payments that you are gonna make in an annuity, in savings your money, and the loan repayment in different terms. And thank you so much. Here I end my presentation.